Hello, everyone. Um, this is a summary of session one on practical indices for the Bayesian paradigm. I introduced the Bayesian paradigm and discussed the fundamental differences with the frequentist approach. The frequentist approach assumes the existence of a parent population was fixed parameters we want to estimate. It aims to estimate the true value of a parameters, assuming that the data are randomly sampled from a parent distribution, usually a normal distribution. On the other hand, the Bayesian approach considers the data are what they are, based on the observed data and a prior belief about the result. In the Bayesian framework, to characterize the strength of uncertainty of a parameters, we describe its posterior distribution. We introduced the Bayesian workflow as a process for updating a beliefs or prior using the data or the likelihood and drawing interpretable conclusion from posterior distribution. We discussed different type of priors ranging from flat priors, priors that have no impact on posterior values, to informative priors, a prior where we use prior knowledge to specify a prior with best guess of the prior means and use prior knowledge to specify a distribution of parameter value. And finally, weakly informative priors. We have reviewed the similarities and differences between frequentist and Bayesian statistics. We have seen that adopting the Bayesian framework is more a shift in a paradigm than a change in the methodology. We have seen how Bayesian inference produces posterior distribution over parameters, and we learn how to characterize uncertainty and interpret result using a credible interval, which quantify the effect of significance or probability of direction, which indicate how confidently a parameter is positive or negative. We introduce also region of practical equivalence or ROP, which help assessing practical relevance and Bayes factors which allow comparing models or testing hypotheses. In many situations, we want to know whether the inclusion of a parameter predictor improves our model. We introduced the Bayesian model averaging to answer the following question. Do models that include predictor X explain the observed data better than those that do not? All these indices are part of the principled Bayesian workflow, from specifying priors to computing the posterior to summarizing, visualizing, and evaluating inferential claims. They help move from binary decision to gradual interpretable evidence. In the next session, you will be introduced to user-friendly tools for applying all this method. So see you at our next session.